When you've tallied the counts of a categorical variable, your next job is to turn those numbers into a picture. Two of the simplest pictures, bar charts and pie charts, seem deceptively alike. Each shows categories and their sizes. But as we'll see, they serve different purposes and come with different design rules. As we have already seen in a previous video, a bar chart is one of the most common and effective ways to visualize categorical data. It displays distinct categories along one axis and represents a numerical value for each category, such as a count, proportion, or percentage, using the length of a bar along the other axis. Bar charts can be drawn with bars oriented vertically, often called column charts, or horizontally, depending on which layout best supports readability. A defining feature of bar charts is that the bars are separated by gaps. These gaps signal that the categories are discrete and unordered, distinguishing bar charts from histograms, which display continuous data with adjacent bins. The axis, along which the bars extend, typically starts at 0, ensuring that bar lengths accurately reflect the magnitudes being compared. Bar charts are especially effective because humans are very good at comparing lengths that share a common baseline. This makes it easy to see which categories are larger or smaller, to compare differences across groups, and to identify patterns or outliers at a glance. For this reason, bar charts are a natural choice for summarizing frequency tables, relative frequency tables, and summary statistics across categories. Bar charts are also flexible. They can be used to display raw counts, percentages, averages, or other summary measures as long as the underlying variable is categorical. When categories have long labels or there are many of them, horizontal bar charts often improve readability. In more advanced settings, grouped or stacked bar charts can be used to compare categories across additional variables. Because of their clarity and versatility, bar charts are often the first visualization used to explore categorical data and to communicate results to a broad audience. Suppose a hospital records the blood type A, B, or O of 200 randomly chosen donors. The counts are shown in the table below along with a bar chart. Notice that the bars are separated and can be reordered to make patterns easy to see. The vertical bar chart emphasizes how common type O is relative to the others. You could flip the axis to make a horizontal bar chart if your category names are long, or if you prefer to read labels on the y-axis. Bar charts are powerful because they encode values using length which humans perceive accurately when bars share a common baseline. Poor design choices can undermine that strength and unintentionally or intentionally mislead the reader. The following guidelines help ensure that bar charts communicate information honestly and clearly. Because bar charts represent magnitude through bar length, the axis should almost always start at 0. Truncating the axis exaggerates differences by making small changes appear visually dramatic. While truncated axes are sometimes acceptable for line charts, they are almost always misleading for bar charts. What goes wrong if you don't? Two categories with similar values may appear drastically different, leading readers to overestimate the importance of this difference. Bars should be evenly spaced with visible gaps between them. The gaps reinforce that categories are discrete, not continuous, and help the eye separate groups cleanly. What goes wrong if you don't? Inconsistent or missing gaps can make bars blend together, confusing the chart with a histogram or suggesting unintended relationships. The order of bars should help the reader understand the data. Common choices include alphabetical order, chronological order, or ordering by value. A deliberate ordering allows patterns and comparisons to emerge naturally. What goes wrong if you don't? Random or arbitrary ordering forces the reader to work harder and can hide meaningful trends. Decorative elements such as 3D bars, shadows, gradients, icons, or excessive labels do not add information. Instead, they distort perception, make values harder to compare, and distract from the data itself. What goes wrong if you don't? 3D effects change apparent bar lengths depending on viewing angle, and visual clutter overwhelms the message. Each of these principles protects the integrity of the visual message. Bar charts are most effective when they are simple, proportional, and transparent. Violating these guidelines can exaggerate differences, obscure patterns, or mislead readers, sometimes unintentionally, sometimes not. Following these design tips ensures that your bar charts support accurate interpretation and reinforce, rather than undermine, the credibility of your analysis. A pie chart is a graphical display used to show how a whole is divided into parts. The entire circle represents the total, typically 100% of the observations, and each slice corresponds to a category within a categorical variable. The size of each slice is proportional to the category's share of the total, with larger proportions occupying larger angles and areas of the circle. Pie charts are widely recognized and easy to interpret at a glance. Their circular shape immediately signals a part of a whole relationship, making them intuitive for audiences without formal statistical training. For this reason, pie charts are often used in presentations, reports, and media when the goal is to convey how a total is allocated across a small number of categories. However, pie charts have important limitations. Human perception is better at comparing lengths along a common baseline than comparing angles or areas. As a result, it can be difficult to judge small differences between slices, especially when categories have similar proportions or when the chart contains many slices. Labels can also become crowded as the number of categories increases. Because of these limitations, pie charts work best when there are only a few categories. The proportions differ substantially, or the goal is to emphasize the overall composition rather than precise comparisons. In situations where accurate comparison across categories is important, a bar chart often provides a clearer and more informative alternative. Nonetheless, when used sparingly and appropriately, pie charts can be an effective way to communicate simple part-whole relationships. A dental clinic tracks why patients miss scheduled cleanings. Out of 100 missed appointments, 50 were due to forgetfulness, 20 to fear, 15 to cost, and 15 to other reasons. A pie chart makes the share of each reason obvious. The slices emphasize that half of the missed appointments were simply forgotten. However, imagine adding 3 more reasons of similar size. The slices would become crowded and hard to compare. Pie charts work only when the categories sum to a meaningful whole, and there are no more than a few slices. Although the same categorical data can often be displayed using either a bar chart or a pie chart, the two serve different analytical purposes and are not interchangeable. Choosing the right chart depends on what you want the reader to notice and compare. Use a bar chart when you want to compare values across categories or between groups. Bar charts place values along a common baseline, making differences in magnitude easy to see. This is especially important when categories have similar values or when precise comparisons matter, such as comparing approval ratings across departments or test scores across teaching methods. Use a bar chart when you want to display statistics that do not form a meaningful whole. Many summary statistics, such as averages, medians, rates, or scores, do not add up to 100% and therefore do not represent parts of a single total. A pie chart would be inappropriate in these cases, while a bar chart can display these values clearly and honestly. Use a bar chart when you want to show many categories, even if some are small. Bar charts remain readable with a large number of categories, particularly when sorted or displayed horizontally. Small values can still be compared accurately, whereas tiny pie slices are difficult to see and label. Because bar charts rely on length comparisons, they align well with how people naturally judge quantity. making them the default choice for most categorical comparisons. Use a pie chart only when the values represent parts of a whole that add up to 100%. Pie charts are specifically designed to show how a total is divided among categories. If the data do not represent proportions of a single whole, a pie chart is misleading. Use a pie chart only when the number of categories is small. Pie charts work best with a limited number of slices, ideally no more than 4 or 5. Too many slices make the chart cluttered and difficult to interpret. Use a pie chart only when the goal is to communicate the overall composition, not precise differences. Pie charts are effective for conveying the big picture, such as showing that one category dominates the total, rather than for comparing closely sized categories. If you find yourself squinting at a pie chart to decide which slice is larger, that's a sign the chart is doing too much. In those cases, switch to a bar chart. Because humans are far better at judging lengths than angles or areas, bar charts almost always provide clearer and more accurate comparisons. In practice, bar charts should be your default choice, with pie charts reserved for simple, high-level part of a whole messages. Sometimes you have two categorical variables and want to see how their categories interact. We introduced two-way tables in a previous video. Here's how to graph them. A clustered side-by-side bar chart groups bars for each level of a second variable next to each other so you can compare across groups. For example, imagine you survey 120 patients about how satisfied they were with a new physical therapy program. Satisfied, neutral, dissatisfied, and record whether they were in the treatment or control group. A clustered bar chart shows differences in satisfaction between the two groups. In a stacked bar chart, bars for each category are stacked atop one another. This emphasizes the total size of each category, but makes it harder to compare the segments across stacks. You might use a stacked chart to show how types of injuries, sprain, fracture, other, contribute to emergency visits across departments. If you convert each bar to 100% of its height, you get a 100% stacked bar chart that highlights composition within each group. Stacked bars are useful when you care about the total across categories, but they hide patterns in the middle segments. In the last plot, you can easily compare the overall emergency visits across departments and the share of fractures. But it's harder to compare the other injuries across departments because their segments float at different heights. If your goal is to compare subgroups, a clustered bar chart is usually better.